I couldn't be here. As you know, Connor's sick, so bear with me. I need you to behave yourselves, please. But we're going to do 4.1a, so if you'll get out your notes, get those started as usual. I'll give you a second to copy this down. And for those of you guys that were gone yesterday for your test, makeups will be Tuesday after school. I should be back on Monday so we can talk again, but makeups will be Tuesday after school. Okay, today we're going to start talking about systems of equations. Chapter 4 is all about systems of equations. And what a system of equations is two equations with two different variables. Normally the variables we have are x's and y's. So far all the equations we've done have been with one variable in them. Now we're going to get a little bit more complicated, where we're going to have two equations with two variables. And because it has two variables, you need that second equation in order to be able to solve it. There's three different ways to solve a system of equations. The first way is by graphing. We should be able to graph the two equations and see where the solution is, and I'll talk about that in a second. The second way is by substitution. Substituting one thing in for another and solving that way. The third way is elimination. Okay. We're going to do all three ways. You're expected to know all three ways for your test. So on your test, if I ask you to solve by graphing, you have to solve it by graphing. When I ask you to solve by substitution, you have to solve it by substitution. And again, if I ask you to solve by elimination, you have to solve it by elimination. Okay, there are three ways. Before we go ahead and do the three ways, let's do our first example. Example number 1 says to determine if the point 2, -4 is the solution to that system of equations. So once we get a solution, once we get an x and a y value, can we tell if that's the right solution? So that's what this is asking us. If we have the point 2, -4, how do we know if it's a solution or not? Okay. In the point 2, -4, the 2 represents the x value. The -4 represents the y value. So I should be able to plug in 2 wherever I see an x and -4 wherever I see a y to see if it works in my system of equations. But it has to work for both equations in order to be a solution. So I'm going to plug it into my first one. My first equation says y, but instead of y, I'm going to plug in a -4. Plus 2 times x, but instead of x, I'm going to plug in a 2. And hopefully that equals 0. If it does, I know that that's a solution to that part of my equation. When I simplify this, -4 plus +4 does equal 0. So I know the point at least works for my first equation. But in order to be a solution to the system of equations, it has to work for both equations. So I also have to plug my information in to my second equation. My second equation says 2 times y, but instead of y, I'm going to plug in a -4 equals -x, but x is 2, minus 6. Let's simplify this down. On my left side, 2 times -4, -8. On my right side, -2 minus 6 more is -8. -8 does equal -8, so it works for that part of my equation. Since it works for both equations, then I know that this is a solution to my system of equations. The point 2, -4 is a solution. If it didn't work for one of them, then it would not be a solution to my system of equations. All right, so now that we can tell if our solutions are right, let's go ahead and do one of each. We're going to do one example on graphing. We're going to do one example on substitution, and we're going to do one example on elimination. We're going to do notes a little bit different today. We're going to separate them into two different columns. On the left column, I'm going to write down the steps. I'm going to actually write out what the steps are. On the right column, we're going to show the work. So that way when you go home this weekend and you're trying to do these examples, you should not only be able to read through the steps, but you should also be able to follow along the work. So you can use it as a reference to do your homework. I'll give you a second to copy this down. There are 5 steps to grasp. Okay, when the problem asks us to solve this system by graphing, our first step before we can even graph it is to make sure that it looks like an equation of a line. So our first step is to make sure that I put both equations into y equals mx plus b. I need to make it look like a line before I can graph the line. Okay, my first equation does not quite look like y equals mx plus b. So let's go ahead and solve it and make it look like y equals mx plus b. Here's my first equation, and if I'm trying to get y by itself, I need to get that negative 2x to the other side, so I'm going to add it over. My new equation now says y equals 2x plus 1. Does that look like y equals mx plus b? Okay. My second equation already looks like it's in y equals mx plus b. So now that I have those two equations, and they look like equations of lines, y equals mx plus b, we've got to start graphing it. The first step, anytime I go to graph something, by using my equations of my lines, is I'm going to plot the y-intercept. I need a starting point. That starting point is going to be my y-intercept. On my first equation, my y-intercept is positive 1. Making sure I go on my y, I'm going to go up to positive 1 and make a dot. My second step is I'm going to plot my slope. I'm going to plot the slope. The slope of my first equation is 2, or 2 over 1. I'm going to go up 2, right 1, up 2, right 1. You can do as many dots as you want to. You can go up 2, right 1, or could I also go down 2, left 1, down 2, left 1. The more dots you do, the more accurate you're going to be. Okay? My last step is I'm going to connect the dots. Hopefully with a straight line, the straighter the better, the more accurate it's going to be when you graph your other line. Okay? So here's my first line, y equals 2x plus 1. Let's repeat steps 2, 3, and 4 for my second line. My second line has a y-intercept of positive 4, so I'm going to go up to positive 4 on my y and make a dot. The slope of my second line is a negative 1, an invisible negative 1, so I'm going to go negative 1 over 1. I'm going to go down 1, right 1, down 1, right 1. My slope is negative, so if I were driving a car on this, my car should be going downhill. If it's not, you did something wrong, so make sure your car is going downhill because it's a negative slope. I'm going to go ahead and connect my dots. So now I have my system of equations graphed. Now that it's graphed, though, how do I figure out what the solution is? Well, the solution is two numbers. It's an x and it's a y. And it happens to be the point that they cross at. The solution to a system of equations is the point that they cross at. So what point do they cross at? On this graph, it looks like these two systems, these two lines, cross at the point 1, 3, 1, 3. So this should be my solution to my system of equations. X equals 1 and y equals 3. How could I double check that that answer is right? Could I do what I did in the first example and plug it in to my equation? If I plug in my y and I plug in my x, does it work for both equations? For this first one, 3 equals 2 plus 1, 3 does equal 3, so it works in that first one. If I plug it into my second one, 3 equals -1 plus 4. -1 plus 4 is also 3, so it works in my second one. You should be able to get 100% on your quiz and on your test on Chapter 4 by checking your solutions. You should be able to get 100% on your homework tonight, any quizzes we have in Chapter 4, and on your Chapter 4 test, because you can check all of your solutions. I plugged it back in, and it worked for both of them, 1, 3. Okay, that's for graphing. Put it in y equals mx plus b, graph it, see where they cross. All right, our next example is solving by substitution. Solving by substitution. We're going to do the notes the same way. We're going to do the steps on the left. We're going to do the work on the right. I'll give you a second to copy that down. There are 4 steps for substitution. All right, anytime your question asks you to solve by substitution, your first step is you need to get one of your equations. It doesn't matter which one, but you need to get one of your equations to either say x equals or y equals. You want one of your equations to either say x equals or y equals. So do either of our equations say x equals or y equals? It looks like the first one already does for us, right? This first equation says y equals all of that stuff, x minus 3. If neither of your equations said x equals or y equals, then you would have to manipulate one. You'd have to move things around so that it said x equals or y equals. Since ours is already solved for us, the top one, we're going to go ahead and use it. Okay? Now that our first equation says x equals or y equals, our second step is we're going to substitute that stuff in into our other equation. Our first equation says y equals x minus 3. We're going to take then that x minus 3 and we're going to substitute it in for our other equation. Now are we going to substitute it in for x or are we going to substitute it in for y? We're going to substitute it in for y because that's what it says it equals. So I'm going to take my second equation, but instead of y, what am I substituting in? I'm substituting in that x minus 3 because that's what it says y equals. Okay. My next step, my step number 3, is I'm going to solve that new equation that I just made. You might have to distribute. You might have to combine like terms. Okay, we're going to solve it. This is just an algebra equation. I have an x. I have a positive 1 if you want to put a positive 1 in there that I'm going to distribute. 1 times x is just another x. 1 times negative 3 is just that negative 3 equal to 5. I'm going to combine like terms, so I have a 1x plus a 1x. They're on the same side, so 1x plus 1x is 2x minus 3 equals 5. I'm going to keep solving. I'm going to get rid of my 3 by adding. So I get 2x equals 8. I'm going to get rid of my 2 by dividing. And I get x equals 4. I'm halfway done, right? I'm looking for an x and a y value. I found an x now. I know that x equals 4. So if x equals 4, how do I figure out what the y value is? If x equals 4, could I plug that in to one of my original equations from up above? So that's my step number 4. My last step is I'm going to take that back in and I'm going to plug it into my other equation, my original equation, to find my other value. So I'm going to plug it in to find my y value. If x equals 4, I should be able to find y by plugging it back into one of my original equations. It doesn't matter which one. You should be able to plug it into either the top one or the bottom one. and you should still get the same answer. So what was our top equation? Y equals x minus 3. My top equation was y equals x minus 3. What did we say x was? 4? So what is 4 minus 3? 1. So do I have a solution to this system of equations? Do I have an x value? Do I have a y value? We're always going to write our solution as a point. So the solution to this system of equations would be 4, 1. 4, 1. Again, you could double check that that answer is right by plugging it back in. You could plug it into your two originals, making sure that it works for both of them to see if that equation, those numbers work for both equations. Okay, substitution. We've got one more. Let's do an example for elimination. So our last example, this one says solve by elimination. There are 4 steps. I'll give you a second to copy that one down. If you look at this one and you tried to solve by graphing, and I tried to put this first one in y equals mx plus b, I would get 5y equals, if I subtracted that 3x over, I would get negative 3x minus 5, and I could graph it, but I'd have to be doing much more steps, right? And sometimes, like let's say this was a 4. And I tried to solve it by graphing, and I divided everything by 4, I would get the equation y equals negative 3/4 x minus 10/4, or 5/2. I guess you could graph it. What would be your y-intercept? Negative 5/2. What is negative 5/2? Where is negative 5/2? What's 5/2? What, 2.5? So you'd have to like graph in the middle of something, right? So it gets kind of nasty. So instead of always solving it the same way, that's why we learned 3 different ways. We're going to learn a third way called elimination. This is probably the method that you're going to use the most, that you're going to like the most, to solve a system of equations. To solve by elimination, your first step is to arrange your equations in columns. Running in there. Columns. Arrange your equations into columns. What I mean by that is that all of your x's should be underneath each other. All of your y's should be underneath each other. All of your equal to signs should be underneath each other. And all of your regular numbers should be underneath each other. It doesn't have to be in that order, but all of your like things should be together. All of your y's, all of your equal to signs, all of your numbers, all of your x's should be arranged in columns. So does our example have the x's underneath each other? Looks like it. Does it have the y's underneath each other? Yeah. Does it have the equal to signs underneath each other? And does it have the regular numbers underneath each other? So it looks like this one is already set up for us. It's already in columns for us, so that's kind of nice. If it wasn't in columns, you would have to rearrange your information. You'd have to move things around in your equations so that they were in the correct columns. Okay? Now that they're in the correct columns, my second step for elimination is to make either my x's or my y's opposites. Make either your x's or your y's opposite. It doesn't matter which one, but make either your x's or your y's opposite. Well, what do I mean by opposite? What's the opposite of positive 7? Negative 7. What's the opposite of negative 12? Positive 12, right? So I need to make my x values the same number, but one positive and one negative. Or my y values the same number, one positive or one negative. I don't want to do both, I just want to do one. So it doesn't matter which one you want to do. Let's do y's in this problem. If I wanted to make my y's opposite, what number would I need them both to be so that they would be opposites? Another way of saying that is if you kind of think about a common denominator. If I have the denominator 5 and 2, what would my common denominator between 5 and 2 be? It would be 10, right? So I need one of them to be a positive 10, and I need one of them to be a negative 10. So that means I need to figure out, what do I have to multiply this 5 by to get it to be a 10? I have to multiply it by 2. But I can't just multiply the 5 by 2. I've got to multiply everything by 2 to keep it balanced. So I'm going to multiply everything in that top equation by 2. That'll give me a positive 10 in front of my y. If my top equation has a positive 10, that means I want my bottom equation to have a negative 10, so that they'll be opposites. So that means, what do I need to multiply that negative 2 by to get it to be a negative 10? 5. But I need to multiply everybody to keep it balanced. Let's do that. 2 times 3x, 6x. 2 times 5y, 10y. 2 times negative 10, don't forget to multiply the negative 10. We're going to make it a negative 20. I'm going to do the same thing with my second equation. Let's multiply everything through by 5. 5 times 2x is 10x. 5 times negative 2y is negative 10y. And 5 times 4 is 20. Okay? Are you okay with that? Let's stop for a second. What if I wanted to make my x's opposite? Instead of making my y's opposite, what if I wanted to make my x's opposite? What would they have to be? What number would I need to get them to be in order to be opposites? There's a 3 and a 2 right now. What would kind of be the common denominator between 3 and 2? 6? So I could multiply the top one by 2. That'll get me a 6. But then that means I would have to multiply the bottom one by what? Negative 3, so that would be a negative 6, and then those would be opposites. You'll get the same answer in the end, so it doesn't matter which one you do. All right? Okay, let's go back to my y's. Now that I've made them opposite, my third step is I'm going to add those two equations together. I'm going to take my new equations that I made, and I'm going to add them together. So what is 6x plus 10x? 16x. What is positive 10y minus 10y? 0, right? Don't they cancel out? And that's what I want. That's why it's called elimination. I want to get one of my variables to go away, to eliminate. That's why I needed to make them opposite. All right, on the other side, what's negative 20 plus 20? Uh-oh, those go away too. So I have a 0 on that side. That's okay. Let's keep going. If I want to get x by itself, how do I get that 16 away? I divide. Can't give me an answer. Don't leave it 0 over 16. What is 0 divided by 16? 0. And it's okay to be 0. 0 is a number. So we have x equals 0. Are we done? Not quite. If x equals 0, we still need a y value. How do you think I'm going to get a y value if x equals 0? Let's plug it in. My last equation, or my last step then, is to, I guess we still need to solve that last equation with the 16x equals 0. So we solved it and plug in. So I'm going to kind of combine two steps in one. We added the two equations. We got x equals 0. And now we have to plug it back in to find our y. Where do I plug it in, though? Well, I'm going to plug it in to one of my original equations. It doesn't matter which one. I could plug it into the top one or the bottom one, and I should still get the same answer. So would you like to plug it into the top or the bottom? Let's go ahead and do the top. If I plug it into the top, what was my top? 3 times x, but instead of x, we're going to plug in 0 plus 5y equals negative 10, right? That was our top equation. I plugged in 0 for x. What is 3 times 0? Just 0, right? So then I have 5y equals negative 10. If I want to get y by itself, I have to divide by 5. And so I get y equals negative 2. Do I have an x and a y? So my solution to this system of equations would be 0, comma, -2. I can get 100% of my homework by checking that answer. We use the top one to get the y. So could I use my bottom one to check? My bottom equation was this, 2x minus 2y equals 4, right? Could I plug in my numbers and see if it works? What did we say x was? 0? What's y? -2 equals 4. What's 2 times 0? It's just 0. What's -2 times -2? +4. Does 4 equal 4? Yep. So I know it works for my top one and my bottom one. 0, -2 is the correct answer. You should be able to get 100% on your homework tonight and on your test over chapter 4. Okay? Your homework tonight, your homework this weekend is your 4.1A worksheet. Remember, it's triple jeopardy. It's worth triple the amount of points, so 30 points compared to the normal 10. I need you to make sure that you're working, you're behaving yourself. You have your homework complete on Monday. As usual, I have the student answer key. You can check it as you're going to make sure you're doing it right, but you should be able to check yourself by plugging numbers back in. All right, guys, have a good weekend. See you Monday.